Welcome to multiple enclosed regions between curves. So note, sometimes functions will intersect more than twice. So sometimes two functions intersect more than twice, or more than two times. And so that means that there will be multiple enclosed regions between the curves. So therefore, there may be multiple enclosed regions between curves. And so for each region, you will have to check which function is on top. So for an example, let's go ahead and find the total area enclosed between f of x equals cosine of x and g of x equals 1 minus 2 over pi x. So for the very first thing we're going to do, let's just go ahead and graph the functions. So we'll start by graphing the functions. So if we draw the graph, for cosine, we know that we start at the point 0, 1. We pass through the point pi over 2, 0, then go down to pi negative 1, pass through the point 3 pi over 2, 0. We also go through the point negative pi over 2, 0. So we have our curve. For 1 minus 2 pi over x, we would have a y-intercept of 1. Then we will go down 2 if we go over by pi. Right? So if we view negative 2 as our rise and pi as our run, we will go through the point at pi negative 1. Along the way, we happen to pass through the point pi over 2, 0. Then from there on out, the line will be well out of the range for cosine. So those will be our only 3 points of intersection. So we intersect at the point 0, 1. Again at the point pi over 2, 0. And then again at the point pi negative 1. The region that we are looking at, therefore, we have the region above our line and below cosine between 0 and pi over 2. And then we have our region above cosine and below the line from pi over 2 to pi. So we have 2 regions. first region, again, is above g of x and below f of x, between x equals 0 and x equals pi over 2. So we can find that area for that first region. Let me actually switch colors. So the area for the first region, we would be looking at the integral from 0 to pi over 2 of g of x, sorry, of f of x minus g of x, top minus bottom, dx, otherwise known as the integral from 0 to pi over 2 of cosine of x minus, in parentheses, 1 minus 2 over pi x, and then dx. So this is the integral from 0 to pi over 2 of cosine of x minus 1 plus 2 over pi x dx. That, of course, we know how to integrate. This becomes, we have sine of x minus x, and then we would have plus 1 over pi x squared, evaluating from 0 to pi over 2. So we have sine of pi over 2 minus pi over 2 plus 1 over pi times pi over 2 squared, then minus sine of 0 minus 0 plus 1 over pi times 0 squared. Oh, all of those terms with 0 plugged in are 0, since sine of 0 is 0. 0 is obviously 0. And 1 over pi times 0 squared is 0. Sine of pi over 2 is 1. So we are looking at 1 minus pi over 2, and then plus a pi over 4. And we wind up with 1 minus pi over 4. For our next region, so going on to our second region, if we look back at our graph, the second region was above cosine, so above f of x and below g of x, between pi over 2 and pi. So now we are looking at above f of x, below g of x, between x equals pi over 2 and x equals pi. So in this case, the area here, we would be looking at the integral from pi over 2 to pi of, this time g of x is on top, so we would do g of x minus f of x dx. So we are looking at the integral from pi over 2 to pi of 1 minus 2 over pi times x minus cosine of x dx. That, of course, we can integrate. This becomes x minus 1 over pi times x squared minus sine of x evaluated at pi over 2 and pi. Plugging in, we are looking at pi minus 1 over pi times pi squared minus sine of pi. Then from that, we are subtracting off pi over 2 minus 1 over pi times pi over 2 squared minus sine of pi over 2. Again, sine of pi is 0. Sine of pi over 2 is 1. So we are looking at pi minus pi, which is just 0. And then we are subtracting off pi over 2 and adding on pi over 4. So from here, we wind up with, sorry, I forgot my plus 1 on the end there. So we had a minus -1, so that will go to plus 1. And this winds up with exactly what we had before. We get 1 minus pi over 4 again. Those two regions were identical, just kind of rotations of each other. So it does work out that they are the same. So from here, we go into our total area. So the total area, we would just do region 1 plus region 2. So we are looking at 1 minus pi over 4 plus 1 minus pi over 4. And we wind up with 2 minus 2 pi over 4, or 2 minus pi over 2. So if we have those multiple intersections that create multiple regions, just find the area of each region separately and then add them all together.